The first thing that we're going to go back over are the different sections of the periodic table. Remember that we labeled 3 sections, and we started with what we called the representative elements. Take your first color, and above the periodic table, we're going to write representative elements. We said that the representative elements were 2 of our electron configuration blocks on our periodic table. Do you remember which blocks they were? The S block and the P block. Let's label those on our periodic table. We'll do the S block first. The S block is found all the way to the left and includes the alkali metals and the alkaline earth metals. The representative elements also include the P block. That's the block on the right-hand side of the periodic table. Notice how I sectioned off helium because it really belongs in the S block, not the P block. But since we're labeling the representative elements all together, both blocks are included anyway. Let's draw some arrows to show that these sections outlined in red are the representative elements. Now you'll need another color. The next section of the periodic table that we talked about was the D block elements. Remember that the D block is right in the middle. The D block elements are known as the transition metals. And includes all of those elements whose electron configuration end with D. Now you need another color. The third section of the periodic table is the F block elements. Remember, when we talked about electron configurations, we said that the F block elements are actually found in between the S and the D block. But most of the time, they're shown down below due to paper size. The F block elements are known as the inner transition metals. And they're made up of 2 different series of elements. The lanthanides named after the first element in that row, lanthanum, and the actinides, named after the first element in that row, actinium. Here you have the 3 sections of the periodic table. Let's pause for a minute and switch to the periodic table at the bottom of this page. For this next periodic table, we'll be reviewing the regions or the types of elements on the periodic table. For this periodic table, you will need 4 colors. We'll start with the largest region of the periodic table. Do you remember what kinds of elements make up the largest region? Most of the elements on the periodic table are metals, and we need to remember that the metals are found underneath and to the left of the staircase. Let's also list some of the properties of these types of elements. Metals are lustrous, which means they're shiny. They're good conductors of heat and electricity. And they are malleable, which means they can be flattened, and ductile, which means they can be stretched into a wire. The metals include everything to the left of the staircase except hydrogen. Take your regular pen or pencil and let's mark the staircase so that we remember where it is. It starts on the side of boron and goes down and over until you get to the bottom right-hand corner. Take your next color. The opposite of the metals are the nonmetals, and those are found above and to the right of the staircase. We'll also put some of their properties here. The opposite of lustrous is dull. They don't conduct, so rather than being conductors, they are insulators. And instead of being malleable and ductile, they are very brittle solids. Now we've taken care of the left side of the stairs and the right side of the stairs. Let's remember what's actually on the stairs. And those are the semimetals, otherwise known as the metalloids. I'm going to list their properties down here at the bottom because I don't have enough space to write on the stairs. The semimetals and the metalloids share properties of both metals and nonmetals. And we talked about the most important of those properties being that they are semiconductors. The other thing that we'll do is shade in those elements along the staircase that are considered to be semi-metals. Boron is the first one, then silicon and germanium, arsenic and antimony, tellurium and astatine. We talked about one last special type of nonmetals, and those were the noble gases. The noble gases are only found in the last right-hand column. Let's put their properties over here since we're running out of space. The noble gases are called noble because they are very unreactive. They are also colorless, odorless, and tasteless. Let's pause here so you can switch to your next page of blank periodic tables. For this next periodic table, we'll be reviewing the different phases of the elements at STP and also which ones are diatomic. You will need 4 colors for this periodic table. First, let's put a title at the top. We are going to review the phases at STP. Remember, STP stands for Standard Temperature and Pressure. And the numbers for those are 0 degrees C and 1 atmosphere. You should remember that there are only 2 things that are liquids on the periodic table. Let's make a little color key here in the middle. I'm going to use red to represent liquids because that's the color of the letters of the 2 things that are liquids on our periodic table on the wall. Look at the periodic table on the wall and figure out which 2 things are liquids. Mercury and bromine. Let's write those symbols in the correct boxes. Mercury is in the D block. It's in the last column of the D block, and it's the 3rd box down, Hg. Bromine is in the halogens. That's the last column before the noble gases, and it's the 3rd box down, Br for bromine. Next, let's mark which ones are gases. On the periodic table on the wall, green letters stand for gases. Look at the periodic table on the wall and decide which elements we need to fill in. Hydrogen is first. Then we have all of the noble gases: helium, neon, argon, krypton, xenon, radon, and the new one at the bottom whose symbol is Og. Then we also have nitrogen, oxygen, fluorine, and chlorine. Everything else on the periodic table is a solid. The colors of the solid letters are blue. Last, let's remember which elements are diatomic. Remember that diatomic means that instead of being found as single atoms in nature, they are found as pairs of atoms. The elements that are found as pairs of atoms include hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. Let's outline those on our periodic table. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. We could put iodine's symbol in with blue, since iodine is normally a solid. Last thing for this periodic table is, what was our trick for remembering the diatomic elements? Take the symbols and arrange them into a word. BRINCLHOF. Brinkelhoff. If you can remember the word Brinkelhoff, then you can remember your 7 diatomic elements. Let's pause here to switch to the last periodic table. On this last periodic table, we're just going to review 2 things: periods and groups or families. Notice that it says underneath, periods are otherwise known as series. Everything in the same period has the same number of filled principal energy levels, and the periods go left to right. So these are the rows. Let's go up to our periodic table and number those rows just like we numbered our energy levels when we did electron configurations. So row 1, 2, 3, 4, 5, 6, and 7. Periods go across, and there are 7 of them. For your last color, we'll label the groups or families. Everything in a group or family has the same number of valence electrons, and the groups and families go up and down. They're numbered starting on the left up to 18. There's group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18.